Okay. Hey everybody. Should be live now. Interesting. So my mic has these like reduce. Like how does this sound compared to A versus B? B should have more like white noise in the background. I'll keep it somewhere like there. Okay. Cool. So yeah, hi everybody. We'll give a few minutes here. I'll go ping the Discord, let some people get on, and then we'll do some lovely. Lovely. Awesome. There's that, and then I'll switch to my screen here and make this a touch bigger. And I will, where's Keycaster? There, now my keystrokes are right there. Hello, Yash Sharma. I don't remember seeing your name on stream before. Is this your first time here? We'll start in 1.5 minutes. It's kind of cold. Oh, I knew I was forgetting something. Here we go. There. First time saw me on your YouTube homepage. Cool. Trying to decide whether or not to put on a hoodie. It's too cold. Okay. All right, well, let's just jump into it. So, can I tell something about myself? Ooh, like what about myself in particular? As far as like the stream goes, I've been doing this for a little over a month now, making videos and streams of my progress. Started as just an operating system, and then I decided to make the operating system in my own language. I haven't actually really started on the operating system. I've just been busy learning C and assembly and stuff. So this is the language that I'm making to write my operating system in. It's called Lovely. So that's what these streams are about. And then most days I also do. Today's kind of a weird day. Normally at this time I'm doing streams for the operating system stuff, but today I'm doing it for the language, because I realized that I'm getting pretty close to wanting to actually start running a bootloader and stuff for the operating system, but this language is really far from ready. So I'm trying to kind of accelerate the language development a little bit so that we're up to speed. Hey Bacon, good morning. You're in the same time zone as me, right? Aren't you, Bacon? Or are you an hour later? No, I think you'd be in the same time zone. Slept in yesterday? No worries. Yeah, today's a later stream. It was really nice being able to sleep in an extra 30 minutes or so this morning. You're an hour behind? Okay. Gotcha, CST. All right, well, yeah, let's jump in. We got some people on now, so. I can move this closer. There we go. Okay. Okay, well, first of all, let's talk about a few things before I actually start. So let me pull up the Discord. It's evening where you are, Yash? Okay. Cool. So I made this poll, right? I said, so first of all, background. There's like a long conversation here about basically, I started with this poll, right? I was like, how should memory be managed in Lovely? And then, namaste. What language is that? I feel like I've heard that before. Is it like Korean or something? And then, okay, so like just over half people said manually, but a bunch of people said garbage collected. Some people said borrow checker, and literally only one person said ARC, automatic reference counting. I feel like this is probably because most people haven't used this. Otherwise, more people would say it because it's not as common as like GC. And then there's a long discussion about what it should be with several people. And then that kind of made me like doubt my process here, because I've been sort of just doing this as I go, like designing it as I go and like fixing things when I hit them. But this kind of made me doubt it. Like maybe we should step back and design stuff first. So I made this poll. Going forward with Lovely, should I step back and make a semi-solid spec and make all language design decisions before I go any further, or should I just keep chugging along and figure stuff out as I go? And then it was like almost a tie, like slightly more people. 12 people said this and 11 people said this, right? Make a spec and design decisions first, or just do it as I go. So then Bacon had the brilliant idea. That means you should only plan a little bit, right? So I kind of like that idea. So I think we might try that. But there are some things I feel like would be wise to think about a little bit before we go much further. What do I need to know to understand your videos? Any particular level of expertise needed in certain areas, or can we learn stuff as we go? Well, I guess I don't know really anything about you. Are you a programmer, or? Yeah, what Bacon said, we're totally learning as we go. Like I really don't know hardly anything about compiler dev or OS dev. I'm just totally learning as I go. And if you want to refer back to the older videos, literally everything I've learned about those two topics has been in these videos. So like there's nothing, I haven't done any work or learning outside of these videos on it. So it's all there if you want it. But I will be writing a bunch of code. So if you're not a programmer, that'll be maybe difficult to follow. But If you are, it shouldn't be. Nothing in here is like really complicated. NAND to Tetris is where you build a computer from the ground up. NAND to Tetris, meaning like a NAND gate, starting at a NAND gate and then going all the way up to like the game Tetris. Is that what that means? You found a great book for me, Kai. It's called The Dragon Book. It's about compilers. Yeah, NAND gates. The Dragon Book? Hold on, let me get some of these apps out of the way. Shoink, okay. What is this Dragon Book? And why is it called the Dragon Book? Because of LLVM? Is this it? Oh, I think I've seen this. I got it. Okay, cool. The OG Book of Compilers. It has a dragon on the cover. Cool. Yeah, maybe I'll check that out. Yash, thank you. I'll check out your videos. Not really a programmer, but I'm learning it because I need it for my research in physics. Awesome. I was a physics minor, and I had to do some programming for simulations and stuff, but it was all in MATLAB. I don't know what you're doing it in. When I did it, it was all in MATLAB, and MATLAB is not a nice language. So, yeah, we all love physics here. All right, so let's talk about memory management and Lovely, maybe, for a second. Where's my README? I also would like to. Do you guys think it's a good idea? So I don't think I'm gonna write out the entire language spec and then go implement everything, but maybe write out the spec for the parts I'm implementing as I go, so that I don't have to just write the whole thing at the very end. You know? Does that sound like it kind of makes sense? And that'll also kind of keep us honest and make sure we're like really understanding what we're making. What do you guys think about that? Good idea, bad idea? Sound like a waste of time or a good thing to do? Here's me. This guy. Sounds good to you? What's the plan for the backend? Are you going to port it for LLVM or are you going to have your own VM? We're going to generate assembly ourselves. x64 NASM. That's going to be it. All right. So I'm going to turn I'm going to make like another thing. So we have like a to-do. I think I already did this. Okay, we don't support this yet. That's fine. So this is the to-do. I'm going to make another one called like discussion, where we like discuss stuff. I'm going to take most of the README and put it in there. Like pretty much all this will go into discussion, and then I'm going to turn the README into like a real README. Sound like a good idea? I think so. Okay. So, it's a purpose-built. All right, what's a good description of Lovely? Lovely is a low-level systems programming language designed to be used to create the humble operating system. That's a good description. Typo in file name. Oh yeah, good catch. Bacon. You're gonna be the next Terry Davis. I don't know about that. I don't know about that. Although I am a big Terry Davis fan. Cool. So let's okay, so we'll have a section here that's called like the language. You making something like humbleOS, like everything is built by me? I haven't really decided how much. Yeah, pretty much everything's gonna be built by me. If this thing goes pretty far, I'm not gonna be like, you know how Serenity also is doing that, where like they literally build everything in house and they won't use any libraries. That's really intriguing, but that literally led them to like making their own like browser engine, which is maybe a little bit crazy, right? And which is awesome. Like Ladybird is super cool, but if this thing goes that far, I'll probably just pull in like Chromium or WebKit or something. But as far as like making the kernel, yeah, I'll try to do everything myself. Or I'll just, you know, start accepting lots of PRs at that point and not do everything myself, but we'll see. We'll see. Yes, lovely as our holy see. Exactly. It's probably going to be a little bit less holy though. All right, the language. So we have like, all right, what do we already have? Everything we have is in this file. Right, so let's just write out some of the syntax. So we're on the same page here. This will be like, I don't know, variable declarations. What do you write here? Variables are declared. Or I'll just say like mutable variables are declared using colon equal, and immutable ones with colon colon. And then we'll have a code example. It'll be like foo colon colon for bar colon colon 2. Mutable var, and this is a immutable var. Am I a university student? Nope, I graduated. All right, you can also declare and initialize onto, or in 2 steps on 2 different lines. Well, okay, I'll say this first. To spec types are inferred, but can be specified like so. Seems we're cooking a spec, am I right? Well, I'm just writing, so, okay, Stefan, we just talked a little bit about this. The spec, we decided to go with Bacon's suggestion, which was to spec a little bit, right? So I'm gonna write spec for all the stuff we create as I go. So I'm just filling in the stuff that we do have already, which is just a very little bit, just like this stuff, right? So I'm just specking that out. And then as we add new things, I'm gonna add them to the spec, like that. But before we go any farther with development, I think I do want to like get a good spec for some of the stuff that'll really change how the language works, like whether it's Arc or GC or MMM or stuff like that. So we will do that. But this is just the spec for what we already have. And welcome to the stream, by the way. Is it a CS degree? Nope, it was in applied mathematics. Types are inferred but can be specified like so. How do we do oh yeah. Foo, int, for. Sorry, this was a typo. This is supposed to be equals. This is supposed to be equal to. Oops. I'll try creating my own language to learn more about compiler stuff. So watching you intrigue me to give it a try. Awesome. That sounds great. I'd love to see it. Or bar int 2. If you specify the type, you can define, or you can declare and initialize a variable in two different, or on two different lines. Like I could say foo int foo gets 3. There we go. How's that? All right, that's variable declarations. What else do we have? We don't really have much else. I mean, we could say data types maybe. Well, what size heading is this? Triple octathor? Okay. Types. Lovely. Supports the following. Following primitive data types. Here comes our great list. Int. What does int look like? Int is just a signed int of size to do. We haven't really talked about that yet, I guess. How we're gonna implement that, but that's okay. Unit equivalent. Is that how you spell equivalent? To void or languages. That's all we have right now is int and unit, no? Oh no, we have booleans. We have booleans. I forgot we made booleans. Bool. True or false. Cool. Those are our types, and then we'll have function expressions. Right, maybe we should have like something else first. Like operators, I don't know. Supports the following operators. Good morning, empathy monster. Arithmetic. So these are arithmetic operators, which would look like plus, which is like addition. We have minus, which is subtraction. We have star, which is multiplication. We have slash, which is division. New bool type, maybe, I know, right? We need that. Exponentiation, I think that's a word. Those are all the arithmetic types we have, I think. We don't have modulo yet. Comparative. We have equals, equals, equality, bang equals, which is inequality. We have less than, which is less than. We have greater than, which is greater than. You mean bitwise? Bitwise operators, you mean, Bacon? Yeah, we don't have bitwise operators yet. I'm just specking out the stuff that we already have, so those are definitely on the, should be on the to-do list. Here, I'll stick them on here. Bitwise operators. There you go. Now they're on the to-do list. Comparative. If it's it can be less than or equal, which means less than or equal. You would consider them arithmetic? I don't know about that. They're not really arithmetic. This is greater than or equal. And then we got like prefix operators, which maybe are like bang, negates a boolean. We also have minus. Well, yeah, negate isn't exactly, negate isn't bitwise, but like XOR and not. Well, we also, I guess we also need you mean like this kind of thing? Because we don't have that yet. You're right. Those would go under like logic, I guess. I thought you meant like these kinds of things. This. Well, how do you describe the negative operator? Making good progress. Thank you. Well, the thing is, you used the caret for exponentiation, and that's used for XOR. Yes. Yes. Well, that's something that I'm aware of. We need to deal with that later on, yeah. We might have to change this. What don't some languages do that? That's kind of ugly though. Oh well, we can figure that out later. So negates an integer. Okay, that's good. Negates an integer. 1 to -1, or I'll just say like n to -n, -n to n. And you know how we made the plus prefix operator? This literally does nothing, I just realized. So I think we should just get rid of it. Lovely doesn't support things that don't do anything. We're gonna go into our Lexer tokens. We're just gonna get rid of it. Tokens. Make sure tests are passing. Okay, before we do this. Operators. Oh wait, no. We need to parse it as a token, but we don't want to parse it as a AST prefix. Prefix operator. Yeah, we don't do that. Tests are passing somehow. Because we never actually used it. Okay. We no longer support that. Oh dear. Shoink. Alright, but you're right. We do need logical operators. We'll stick that over into the to-do. logical operators. All right. What is next, people? What think y'all? All right, function expressions, I guess. Oh, we got operators. Yeah, okay. You should probably name it logical not instead of not if you later want to add bitwise operators. This guy? You mean? Did I call it that? AST. Oh, sure enough, it is called that. Good idea. Logical. I like that. Thank you. Good catch. Although this should really go. Yeah, I'm gonna get rid of this prefix section. I'm gonna make a new thing. This is gonna become infix minus if infix negative if prefix. And this is gonna become a new section here called logical operators. And this is our only one we have, right? So coolio. Parentheses, how in the world do you spell this? Parentheses can be used to, I don't know, group expressions. Hey, ICXD is here. Welcome. Like you could do something like this. You know, 4, 3 times 4 plus, or 4 minus 5. I don't know, plus, whatever. All right, there's that, and then we'll do function expressions maybe. Function expressions. And this would look like, you know, this is like the once in a blue moon. I open up a so this is a GUI editor. Bacon's got to go. He'll be back later. Cool. See you, man. Nathan, hello. Finally managed to catch a stream. Awesome. I'm glad you could catch it. I'm pulling this up just because I want to see the markdown preview. It's kind of cool. Okay. Except this color is kind of bad. Oh dear. Okay, does it have a what's my Everforest, yes. Okay. Everforest. Is this really Everforest? I guess it is. Shucks, it's letting me down. Alright, Capuchin. Here we go. Alright, this just lets me see the preview here. I guess it doesn't really help. Alright, never mind. I take it back. Hello, Alan Rubilar. Rubilar? I don't know how to say that. Alright, function expressions look like function expressions follow the following format, I guess. And it's like fun, parameters, return type, body. Pretty basic. You know what I was thinking about? Do you guys think it'd be cool if we have functions that don't take any parameters? Is it cool to leave off the parentheses or not? Probably not, right? Nathan, I was wondering if you want first class function support. Shouldn't function expression also be a variable declaration? No. This is a variable declaration that's assigning a variable to a function expression, which causes this to be a function type now. Now, it's still first class because I can pass this now into like some thing here. Not this one, right? But, right? Does that make sense? There's a NeoVim plugin called render markdown.nvim that renders the markdown when in normal mode using ASCII UTF symbols. Nathan, you got it? Okay, cool. What? Render markdown. How does that even work? But it can't make like the headings bigger. Because everything is expression. Exactly. Render markdown NeoVim. This thing. Whoa. This is nuts. This is pretty cool. Are we gonna get it? Quick tangent dot files. What's the config look like? Pretty basic. All right, we'll do that. What is it called? Render markdown.lua. Take all this, joink. I don't know what this is. Shouldn't cause any problems though. Cool, and then down here, pull it in. Acquire plugins, render, markdown. Is that just gonna work now? Shoink, it's loading. Okay, now if I go over here and make a markdown file. Oh, it's working. Whoa, wait. This is really cool. If I make another one, oh, it indents it more. This is like the coolest thing ever. And if I go into insert mode, then it goes back to normal. That's super cool. If I do like a code thing and make it like Rust or something. First of all, it has that awesome logo there. Has syntax highlighting. It even makes like a cool background around it. Jeez, wow, thank you so much. This is really neat. All right, we're in business, people. Plugin's pretty good. Also used in Avante. What's Avante? Hi, what is the language name? The language we're making is Lovely. Lovely is the name. All right, cool. Let me restart NeoVim so we can get this. All right, readme. README is looking good. Except it kind of jitters a little bit. That's all right, though. That's not too bad. Should I add this? I mean, it doesn't know about Lovely yet, so, but one day it will, and then we won't want to have to change this. And it's actually kind of adding a little bit of highlighting, which is kind of nice. So we'll do this. Lovely. Lovely. All right. Hello, how long have you been programming for? First line of code, I was probably 12 or 13, and I'm 20 now, so 7 or 8 years. Avante is like Cursor, but less powerful. Okay. Lovely tags in Markdown. I know, right? We need to get those. Yeah, that's the annoying part of the plugin. It looks good in editing, but it can be kind of messy with all the jumping. Yeah. Oh, Avante for NeoVim. I removed the... I did? I don't think so. They all have it. Yeah, they all have it. I'm 15, and I'm also making my programming language. Awesome. Yeah, it's just the formatting. It makes it disappear. This plugin is doing that. All right. Parameters. Function parameters can optionally have 2 labels. One for use inside the function implementation, and one for the call site. And that looks like a fun. How much has it made? Like how much progress have I made? Not a ton yet. I'm parsing and lexing some of the basic syntax, and I'm starting the type checker, but I haven't done a ton yet. Fun, like I can say, I'll say like add. Or what would be a good example? I'll just add more here. So if you only use one label, it will be used in both places. If you don't want to have to provide a label at the call site, use or prefix the label with that thing. And that would look like add first 2-second. We do first plus second. I received a sub and a like. Thank you so much. I'm thinking I might go sort of long today. Like a longer stream. Why not just use one of them? What do you mean by that? Why not just use one of them, the tilde or 2, and make the other the default? Because I could also have done this. Right, and then lorem for the arguments. I'm not sure I understand though. Because this at the call site will look like this. 2, 4. Does that make sense? Video playback is messed up right now because you just updated your Arch install. Nice, Ivy. Just wanted to pop by and say hi. Awesome. Well, hey, Ivy. Thanks for stopping by. Yeah, you asked what would this look like then if I had add fun foobar. Sorry, 2 colons here. Int be called, and like say return int and did something in here. Then you'd call it like this. You'd go add foobar 3, right? If you just use one label, then it's the same inside, like you'd reference it in here the same way you'd reference it out here. If you do this, then you reference it like this in here, but you don't have to add a label out here. And if you do 2 different ones, then you call it foobar in here, but you call it lorem out here. Does that make sense? There's kind of 3 options. So it lets you make really expressive APIs like this, you know, add 3 to 4, which just looks super nice. Cool. So there's that. What is next on the agenda? Do we even have anything else to document? I mean, not really yet. Oh, except comments maybe. Except we already kind of showed that in here. Variable declarations. We'll just do it here anyway. Comments. Comments begin with that and continue to the end of the line. There we go. You're the first programming language creator who capitalized the type's name. You mean like here? I don't think that's true. Yeah, both Swift and Haskell do that too. Swift definitely does this. The weird thing is that something like Rust and TypeScript and stuff, like they'll tell you to capitalize if you define your own type, but they just for some reason they don't capitalize the default built-in types, right? And so that to me seems weird. So I think you should just be consistent and say, okay, all types are uppercase, all variables are lowercase. Doesn't that kind of make sense? I think. But yeah, no, Swift is really consistent like that. They have int and string and all that kind of stuff. You're making this in C or C++? No, I'm making it in Rust. For emulate, its custom types are capitalized and built-in types are lowercase. Okay, yeah, that's how a lot of things are. To me, that just feels like a little bit. I mean, it's fine. Like, it's not a problem, but just a little less consistent maybe than it could be. But you feel like that's the standard in OOP? Yeah. Cool. So let's all right, let's talk about oops. Let's talk about memory management. Well, actually, I'm gonna make a commit real quick. Well, what have I done? I actually started the checker too. What was my last commit? Booleans. Yeah, okay. Updated, readme, started, checker. Push that to master. When am I gonna finish the type checker, bud? All I see is slacking off. Hey. We decided to step back and document a few things so that we have a clear picture of what we're doing before we start trying to implement hard things. So, where that's next is the checker. We're gonna get back to the checker, don't worry. Gleam forces uppercase on types. That's cool. I just want to make sure that, okay, we should be able to see a nice readme now if we go to your repositories. Look, guys, 13 stars on Lovely. Amazing. Isn't this nice? What a great readme. Okay. Documentation is for nerds. We are nerds. All right. So let's talk a little bit. We're going to get to the checker, but first let's just talk a little bit about what we memory management. Are you planning to create this completely solo, or do you plan to accept contributions? Okay, I've been a little bit torn on that. I mean, it's open source, right? But I'm doing it largely as a learning project, which is what makes me, that part of me makes me lean towards doing it totally solo. But the part of me that actually wants it to get done is thinking that it'd be really cool to get contributions, you know? So I don't know, I'm a little bit torn. Part of me wants to like try it solo until I feel like I really understand it and then start taking contributions. Because I feel like if really smart people start contributing, then I'm just like not gonna understand what they're doing, you know? What do you think? What do you guys think? IC says he doesn't think it's a good idea to talk about MM when you haven't even finished the checker. Well, I feel like memory management is gonna really like. Okay, maybe we can finish the checker first. I don't know. IC really wants to see this checker made. Yeah, that totally makes sense. Maybe once it's a bit more developed, you can open it up to help with the boilerplate stuff. Yeah, that's kind of my current thought. I'm thinking like for now I'll try to just keep it all solo, and then once I feel like I actually have my mind around like, or I have like it actually compiling, actually working and stuff, then maybe I'll say, okay, you guys, if you have contributions, make them. But it is, in the meantime, it's open source. Like you can go see the code. So, all right, so yeah, that makes sense, ICXD. All right, we'll make the checker, and then we'll talk about it. You should watch the talks by the creator of Elm. He went through all the ups and downs and has some great lessons. That sounds interesting. What's the name? Where could I find those? All right. So where were we? We have this thing called a checker, which pretty much just holds on to some scopes. Scopes just reference their parent scope. You make a new one by starting with just the one scope that has no parent, meaning it's the global scope. And then you create scopes. This creates a scope, okay, and then you can check a program. But checking a program returns a checked program. A checked program is a vec of checked expression statements. A checked expression statement is really just a wraparound of checked expression. And what's a checked expression, you may ask? Okay. So this comes down to how do we check an expression. Evan Chapliki. Not sure how to say that last name, but okay, cool. I'll check that out. Sounds interesting. All right, how do we check an expression? Well, what does a checked expression even look like? Take a peek at Amulet if you need some guidance. Yeah, I think I kind of mostly remember it, but yeah, we'll definitely take a peek over there in a second. So it's basically it's loosely or it's tightly based on what the AST looks like. So it ends up being an enum of like these things. Correct. Let's look at Amulet. Amulet. Here's the checker. Checked. Checked expression. Here we go. This guy. Span. What's your span? Is this just is that the same as my span? Is that just like the literally in the code where it is for diagnostics and stuff? And why are these span and then the type and this is the type and then the span? Oh, this is the value, I guess. Okay, that makes sense. File ID, start and end. Okay, gotcha. So these are like primitives. Okay. And then gotcha. Yep, don't need types because it's obvious what the type is. Okay. Okay. So we'll start with something really simple like a unit. Wait, do you have these? How do you have these names? No, you don't. Okay, just call it unit. Right, a unit ends up just having span. Span. Where did span come from? I have everything in like these different crates. Part of me wants to kind of like combine these into one thing. Because they're not really very big. What do you guys think? And then I wouldn't have to do these like dependency dances. Should I combine all these? I think I'm going to combine them and not make this a cargo workspace. Yeah, okay, here we go. Gonna make one, how do we gotta do this? We're just gonna steal like, or, I don't know, better yet, might just be to make a, right, here we go. We're gonna make a new the new lovely. I'll say cargo new lovely. What's the link to the amulet project? I'll send it if ICXD is good with that. There it is. Super awesome. He has a Discord and everything too. You guys should all get on it. Okay, active projects. Now we have a new lovely, right? So if I go to new lovely, all right. So I'm gonna have like a new lib.rs, right? All right, I'm gonna break these into like submodules. So I'm gonna have like a I'll keep these in like subdirectories. So I'll have like a lexer first, and then have like a mod.rs, and then in here I'll say like mod lexer. This, all right, and the lexer has two submods, mod span and mod, although span maybe shouldn't even live down here, but for now he will. Mod tokens. These aren't files yet, so we're gonna add a span.rs and a tokens.rs. And then what are they gonna look like? Well, a mod's gonna look a lot like this. Token is gonna look like that. Oops. And then span is gonna look like that. So now these are all pretty happy. And then all right, then we're gonna have a parser. Parser looks like that. Or wait. And then this here, I'm gonna make this bigger. So I'm gonna pull this over onto my other monitor. Make this big, okay. Parser also has a ast.rs. And then we also have a checker. All Alright, now he's got to go in and fix all these problems. Now we have the Lexer. Okay, this is... We need pretty assertions. Okay, that one's fine. These are all fine. Okay, this one's fine too. So, okay. Now do I want to get rid of this? Oh, the only thing is I just made a new project. Shucks. So I just lost all my Git history. I can, what could I do here? All right, ready? I'm going to yeah, that's what I'm doing. And then shoink. Okay, now we have all of these. Now this is no longer this. Get rid of the cargo. Get rid of that too. Actually, while we're at it, and might as well get rid of that. And then how's that? Tests are passing. Cool, alright, we got it. I'm going to switch to single crate from work, or switched from cargo workspace to single crate. I think this is better. Lovely. Okay. So now the checker. All right. Oh yeah, I wanted to bring span. I feel like span doesn't really belong in Elixir. It kind of is a more of a universal concept, if you know what I mean. So maybe I'll just bring this up to the root. Choink. Makes this guy a little bit mad. Where is it being used? Tester passing. Okay. Oh, we don't really have the concept of multiple files yet, so I'll just leave off the file ID for now, but we can add it later. And then mod here. Okay, so this guy takes a. You know what I sometimes wish there was for enums is if there's like a common field. So like, look at this. I'm gonna have a bunch of different things here. All of them are gonna have the span that goes with them. So wouldn't it be kind of cool if I could say something like common span, you know, like they all have a span? I don't know, maybe not. Span, what is a span? Start, why are these just, okay, that's fine. By the way, how much of this is dead code? Yeah, okay, a lot of it. Unit is that, and you have a type ID, so it ends up getting typed. Okay, so type ID is a type ID. Wait, that's actually a type? I probably want to make my own though, don't I? You can make a struct called checked expression, and then you can have the enum called checked expression data or something. Then you can put the span and type ID on the structure. Type ID is just a usize, kind of like this. That's a good idea. Yeah. This becomes data. Common fields go here. So unit doesn't really have any associated data then. Hello, nuclear ducks. You arrived just in time for my scheduled water break. You think you beat me? But shouldn't, if it's unit, we already know the type ID, right? So, well, it's okay. All right. We can also have booleans, right? Cool. We do support bool, which will hold on to a bool, right? I guess this is like a boolean literal. So what do we call it over in the AST? Bool literal. Guess we'll call it that. All right, you got unit, but what other literals do we have? Int literal. which takes I size, right? What is, and literal is an I size, okay. And then we have ident. We could literally just copy this all over. Ident just has the ident name, maybe, in addition to the span and the type ID. The problem is, I think I failed to pass the span all the way through to the AST, so we need to pipe that information through at some point. All right, and then maybe we'll just start with these and then get some tests going so we actually know what we're doing. The span is like the most important part for good error reporting. Yeah, I know. It won't be very difficult, I don't think. I just need to add like another field to those. So, because I have it coming from the Lexer already, it's just not getting through the parser. All right, so if we check a program, it's just gonna, so we're gonna have another function called check expression. I wonder if it'd be better to have a trait. What if I had a trait called checkable? That had something called check. Could even be generic. Takes an entity. Just make functions. But wouldn't this be cleaner? And returns a self. I think this would be cleaner. Probably wouldn't make a difference. Well, let me just see how this would look, because then instead of check program, I'd have, wait, do I even have a check? Yeah, checked program. I just have checked program. I'd like impl checkable program for checked program. And then I would just add this, right? And then it'd go in here. And then these two things gotta live together like that, as opposed to having everything tacked onto here. Because there's not, then I don't have the checker state. That is a good point. What's the checker? Oh, I need the scopes and stuff. All right. Good point. Yeah, I'd have to pass in a checker. That's just no fun. All right, so I'll just make a methods. Worth a try though. Program. All right, so this guy is going to just say, all right, we'll have a function check expression statement. Still missing the mut self. What here? Happy? How's that? Make this a to-do for now. This just returns program in there. First try. Yep. Map. What does this take? A statement, and it'll be, this thing takes a we can just do this point free, I guess. We got issues. Just use a for loop. Missing a collect. That's a good point. Haha! Oh yeah, we don't need no for loop. We can do big brain moves. Okay. Here, alright, so you just have this expression. Current scope ID. Yeah. Good thought. I'll add that when I feel that, when I need it. So Mocab's Nation. What will you name it? What will I name the language? The language is named Lovely. This is basically just going to call out to our other handy function, which is called check expression, which takes a mutt self, an expr, which is a reference to an expression. It returns a checked expression. Yeah. If you want to have type inference 2, you might want to add a type hint ID parameter to that. To what? What would that do? A type hint ID? Look at amulet. Okay, did I search? Type hint ID. Type hint. Type check expression takes a type hint ID. But what is this? Where do you get this? Like, what does this even represent? Unify with this thing. Parsed statement var decal. This guy? You pass the type hint? But what does the type hint represent? Like, where do you get a type hint from? The type hint is like the type on a variable? Oh, like when you say, oh, like this is the int in like a:\int equals 10. Int is the type hint. Gotcha. Okay. Oh, so if this expression were, for example, were like the R value in an assignment expression, then we might have a type hint that we would need to match against. And it would be an error if it didn't match the type hint. Is that what you're telling me? I gotcha. That makes sense. Because like if we have something like if I had something that looked like foo int Tyler cannot infer what the type of that. Yeah, that makes sense. You would specify type on the variable, exactly. But if I had something like foo:\int equals like lorem, this is obviously wrong, right? But if it would get to here, it would be parsing this or checking this expression. It would have a hint of int, an int hint is what we call those. The int hint wouldn't match this, and so it would type error. Then it would tell the expression that, hey, I'm an array of ints. Yeah, I gotcha. That totally makes sense. Cool. Unify with type int again. Unify with type this guy. Shoink. It does the check types for compat. Oh yeah. The type ID with the type hint ID. Very interesting. Intriguing. I'm intrigued. Okay. So we'll try that. We'll try that. See how it goes. So check expression might take do what you want with that information. Sure. Thank you so much. That's really helpful. So I might take a type hint. You gotta go? Alright, no worries. See ya, thanks for the help. Type hint is an option though. Or maybe I'll just add that when I need it. I'll add a to-do here. Add to-do. Add type hint. In the meantime, my monitor just got disconnected. We got technical issues all over. There we go. Very nice. Okay. So check expression. What does check expression actually do is the question. This thing's an enum. A checked expression hey, maybe all of these should have spans. I think maybe these should have spans. All right, so this guy takes an expert. He needs to check it. What does amulet do? We just had it. Takes a scope ID. So it pretty much just has to match over. Right, it can be any of these things. For now, we're just gonna do them all. This is where I sort of want to write some tests. Where do we get these type IDs from? So what is like a If I define a new type, I can just add a new type ID. That's fine. But what if I... Okay, what do you guys, what about like int, for example, is a built-in type. So what's its type ID? Do I just make some sort of like hash map that's like type IDs for the built-in types? Anybody have any thoughts on that? Do you have anything in here about like built-in? What I do in my language is that the type ID is just the index into a vec of types, where type is a data structure containing information about like structure and function args and so on. Gotcha. Yeah, that sounds like a good idea. But what do you do then for built-in types? Checked type. Built-in. This is missing a span. So is this. Hey, just a tip for your language for the assembler, I would highly suggest looking into FASM. When initializing the checker, I populate the type vec with them, then having set values for the built-in so I can easily access them. Gotcha. So you have like it'd be on your checker here, like types is a vec of some type. Check type maybe. And you make like a checked type. Checked type. Then here you initialize with the built-in types. Okay. So checked type has a well, this is a little bit different from like a checked program, right? Because this is Hmm. Some sort of type thing. Because this isn't the same as like one of these. Wow, type checking is hard. All right, well, let me just think of a name, like a scopes type or something, because these are going to be associated with a scope, right? Because you can only use a type in the scope wherein it's valid. I'll just call it for that for now. Okay. I just need to get writing and then fix things later. I'll stick it up there, actually. A scopes type has a name. I don't know. And a scope ID. And then this we'll just say we'll initialize it with our built-in types, I guess. So that's and then okay, so we'll make some new types in here. Scoped type, a new one called int. 0 is the index of this global scope. So we also have one called bool. And then I guess we also have one called unit, right? These are all global. These are built-in types. Okay. I feel like at this point I should go, because I'm gonna not be able to get past all these to-dos, because I need to go through and thread this. Oops, what has happened? thread these spans through. All right, so I'm gonna work on that for a second. But I think something like this will work here. And then we'll just need some sort of like lookup type. Let's write that really quick. Okay, so we'll have you have two different type structs in my language, one from the parsed that has like struct definitions and name types. So struct my struct field would become, okay, still coming some more. Gotcha. Okay, thank you. I'm just gonna input something on a vec of scope types here. You hate that there's a limit on message length. That's kind of annoying. Sorry. Cannot define inherent. Oh no. This is so annoying. I can't make things on this. So let's just make another type real quick. Struct scoped type collection. Scope types, which is literally just a vec. A vec of scoped types. And then this instead becomes types becomes a scope type and then scoped types. Now I can do stuff on that. I also want to make it, because can I like impl bref? Not dref. What do I want? Okay, we'll do it when we get there. Well, how do you make it so like one of these? Yeah. I want to be able to just use it like it is a vec scoped type without .0. Is there some trait for that? I think there is. It is dref, okay. Target, oh, okay, that's how you do it. We'll do that. So let's, one second, impl. dref for scoped types. Type target is a vec of scope types and deref just gets you self.0. Perfect. Okay. That's all I wanted. And then for scope types, I just want to. What was the method I was even trying to add in the first place that I had to do all that for? Oh yeah, like look up type. You pass it like a name. And a scope. And it'll be like self dot find or find, is there a find index? No. How do you find the index of this thing? Is there a Rust equivalent of find index for vec? Position. Oh, there's something called position. Oh, this is an option. Oh yeah, I guess this should return an option. There we go. So now I can look up a type. Except the scope isn't quite right, because if it's, I don't need parent scope, that's fine too. So we actually need to like walk up the tree. Right? So we'll say like This needs to take like the whole vec of scopes. Or we're just making a method on the checker and then it already has all that stuff. I think that'd be better. I think that'd be better. Is that what it is? Yeah. All right, but hold on. Well, let's say like let curve scope equal you have two different type structs in your language. One that comes from parsed code let my struct use my struct no has type named. That then gets resolved into a type ID by looking into a record of parse types that exist in the type vec. It would be resolved to a type ID that has a type like. Gotcha. Thank you. That's helpful. So I don't even have type definitions yet. Yeah. Okay. That does sound confusing. I'm just gonna try to keep bowling through this and see where we get. Curve scope equals wait, what? Okay, yeah. Curve scope might have a parent scope. Let type ID is that this is option. Okay, so we'll say like if let sum right at this point that means we have a type, so we found the type, then we'll return some type ID. Wait, why is this erroring? Oh, because of that. Okay, this is a to-do. The reasons that it isn't just a string from parsed code is because I have array, so an int 5 would become type array, length 5, inner. Yep. The reason for me that made me do it like this is because type aliases should have the same type ID. Okay. Unless you make your type aliases tagged by default, which would be kind of cool. So this means we found one. Right, else we'll have a garbage collector. It's probably going to be ARC, automatic reference counting, with an option to drop down into manual memory management, but we're not sure yet. Say you have alias myInt equals int. Those should both be resolved to type ID 0. So comparison of type is just comparing the type ID and not actually looking at the structure of the type that the ID represents. Gotcha. Yeah, that totally makes sense. Thank you. That's helpful. Else if, okay, so otherwise if parent equals cur scope dot parent scope, then we'll return lookup type with the name being the name, the scope ID being the parent ID. So it's recursive, otherwise we return none. So this will look in your current scope and then walk up the scope tree looking to see if this type is defined. This is pretty cool, actually. I like this function. What language are you building this? This is Rust that I'm writing right now. Oh, I got the yawns. Cool. All right, now I'm going to go through and try to thread these spans through. So we have the span. Okay. Which right now just has a start and an end. Be kind of cool if we translated these into like line and column. Would that be better? Where are we making these in the Lexer? Okay, so I think span should actually say line and column would be better. So hold on one sec. Pub struct new span. Okay, span's actually gonna say the okay, no, we'll make a line. This might not even need to be public. Line is a usize. Column is a usize. What are these errors? There's errors afoot. I don't even know if I need these anymore. I don't think I do. There we go. Now tests are passing. Okay. All right, position is a line and a column. This turns into position, position. And then I'll make a new method on Are you making this language for your OS? Yep, this is what the OS is going to be written in. This will say new, or I'm going to say like from char indices. Is that how you spell that? Plural of index indices. Okay. From char indices. Start text. We're going to say from text. Why not go straight and work on the OS instead of building a whole language? There's C and Rust that get the job done, to be honest. Or is this more of a Terry Davis thing? This is a Terry Davis thing. That's exactly right. No, but actually, I'm just doing this to learn. I'm not doing this to try to finish something very soon. So I figured I'd learn more if I made my own language. Byte start, usize, byte end, then pass them. To Miet. Oh, is Miet that really cool? Yeah, Miet, Rust. This thing. Isn't there another one too? What's that other one? Rust. Rust. Is there like another one that does kind of the same thing? I feel like it looked even better though. Or maybe this was it. This looks pretty good. Is this the main one? Wow, it's very macro based. Source span. What's a source span? It has good language diagnostic support for errors and helps in everything. Okay. Well, yeah, maybe we'll use that. You're saying I don't need line and column then? But see, the problem is when I bootstrap Lovely, like so when Lovely becomes written in itself, I'm not going to be able to use Miet or whatever, however you pronounce that, right? And so I'm wondering, should I even use that now if I'm going to have to roll it out myself later? I'm trying to keep dependencies to a bare minimum. Right now, this is literally just for tests, so I have none. I think I might try to do without that for now. So, but yeah, we can always pull it in later. This just needs to convert there's a 4 6 dot into, oh, like this kind of thing. That's cool. That's actually really interesting. Just make it from a tuple. Huh. But yeah, I'm gonna do line column. So, oh wait, I have these backwards. No, I don't. Yeah. Okay, so line column is position. So from start end. Probably want up here. Okay, wait, hold on. I'm gonna make it's gonna be from char index, which would be index will be a usize. And then can I get a I need text. That's nice. Cool, now I have a deck of those. So then I'm going to say for byte in, or is it of in. So for each byte, I'm gonna say, I'll say let line 1 1. Right, I'm gonna say match byte, not bytes. If it's a new line, if it's a new line, then line plus equals 1 and char equals 1. And then if it's anything else, then we'll just do char plus equals 1. And then I guess this is column, isn't it? And then we'll just do like that. Remember that Rust strings are UTF-8, so that 1 byte is not always 1 char. Yeah, they can be up to 4 bytes. Good point. How's that? Oh wait. forgot to stop at the index. Plus equals 1 if position is greater than or equal to index. I'm probably having off by 1 error. Break. Let's make some tests. I'm not sure if this works, but first let me fill this out. This should be really simple. It just let me make some tests really quick. What is not compiling? Oh. So this new really needs to take a reference to the source. End would be start plus size minus 1, right? If I have this thing, for example, start would be here, size would be 4, so I'd go 1, 2, 3, 4 minus 1. And there we go. Okay. Now we've got other errors. This should be needs to take that. Tester passing. Okay, so now let me test this thing because I'm pretty sure this probably isn't right. Pub. Alright. So I'm gonna make a position from char index. Make sure this is actually working. Sure enough, we got 1 and 2. Okay. Let pause equal if we have something like hi there, and then a new line, and there, and then I am Tom. And we want like say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12th should be an A. Well, the line should be 2, and the column should be 1, 2, 3. All right, we got line. They're both off by 1. Let's do another one right here, so we can see if there's a common problem here, like a multi-line one. Let's do, so this is 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 24, 25. Wait, what was 25? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That should be the E there, which is 1, 2, 3, 4, 5, 6, 7. The 7th on line 3. Oh, sorry, this was supposed to be line 2. Did I count this one right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it should be number 3. Is the other one failing too? They're both off by 1 with a column. All right. So maybe we do this. Ta-da! It works. Okay. So our logic is right. Now we have a more robust span, which is pretty satisfying. And that's coming from the lexer. So now over here in the parser, a token. So this thing ends up making, next token makes a token, right? These tokens now have spans attached to them, which is really fun. So in the parser, AST things, every AST node should have a span attached to it. How do we want to work that? What time is it? 9:30 almost. I started at 7, so it's 2.5 hours. All right, that might be a satisfying spot to start. So next up, I'm gonna make a new. We got a lot of markdown files. I'm gonna make a new one called next up. Use or pipe our new nice spans through the AST so that the checker, or through the AST/parser, so that the checker can access them. Cool. I'll commit. What was my last commit? Made span type better, and yeah, pretty much just that. Push that to master, and awesome. Cool. Thanks everybody for being on, and for all the assistance and help. Really appreciate it a lot. Might do another one later today. Who knows? We'll just see what happens. So I'll let you guys know in the Discord and stuff. But thanks a bunch. Until next time.